welcome back. Good evening once again. Welcome to this video session, Module 2 Homework Part 2. Okay, we shall continue from where we stopped in Part 1. Please, before you continue with this video, please make sure that you have viewed the videos on logic and truth tables. Okay, it's under discrete mathematics on my website. View the videos on logic and truth tables. That way you have a good understanding of the topic. We stopped at question 7 in part 1. So let's go ahead and do the next one, question 8. Question 8. Question 8. Construct a truth table for an example. I'm going to do an example. Not P or Q excuse me, implies not P and not Q. Okay, then it says, explain how this truth table shows whether this statement is a tautology, a contradiction or absurdity, or a contingency. Okay, so here we have two statements here, so it's 4 possibilities. 2 statements means 4 possibilities. So we have a P, we have a Q, we have P or Q, okay? We have negation not P or Q. We have not P, we have not Q, we have not P and not Q. Then we have this here. Not P or Q implies not P and not Q. Okay. I like to use double lines to demarcate my statements from the truth values. I mean, it's just my preference. Okay, so this is 2 statements, so it is 4 possibilities. We have true, false, false. Okay, and then we have true, false, true, false. P or Q, or true or true, true, true or false, true, false or true, true, false or false, false. Negation of this, not true is false, not true is false, not true is false, not false is true. Okay? Not P, not true is false, not true is false, not false, true, not false, true. Not Q, not true is false, not false is true, not true, false, not false, true. Not P and, conjunction, and, not Q, and, false and false is false, false and true, false, true and false, false, true and true, true, and. Okay, the conditional statement, okay, false implies false is true, false implies false is true, False implies false is true. True implies true is true. So these are all, the truth values are all truths. Okay? So this is a tautology. Tautology. Tautology is a statement that is always true. The truth values are all truths. So it is a tautology. Okay? Please view the videos I did on logic and truth tables to get an understanding of the logical connectives. Look at the videos on logical connectives. Logical connectives. And that would make much sense. Alright, and like I said in previous video, you can check your work by also using Google Spreadsheet or Excel. Okay? Excuse me. Google Spreadsheet is free. Excel is not. Microsoft Excel is not. So, but the same way we do it in Google Spreadsheet is the way we do it in Microsoft Excel. Okay. We do number, so this is a tautology. We now do question 9, arguments. Question 9, arguments. Arguments. So we have actually 3. So it says here, we have 9A, 9B, 9C, 3 questions in 9, question 9. It says, write each of the arguments below symbolically. That's write it in symbolic logic. And then explain whether it is valid or not. So determine the validity or invalidity of arguments. So please, in the videos on that playlist, Logic and Truth Tables, view the videos I did on arguments, standard forms of valid arguments, and standard forms of invalid arguments. Okay, very important. Then you will understand this here. So I'm going to use my own example here. 9A. 9A. So we write the argument is, if it is warm outside, then I will walk at the park. If it is warm outside, then in line. If it is warm outside, then I will walk at the park. Okay? The next one, I will not walk at the park. I will not walk at the park. Then the conclusion, therefore, it is not warm outside. It is not warm outside. Okay, so with arguments, because when we did this video, the first thing you do to analyze an argument, the first step, we write the statements. Okay, after writing the statements, we write the premises and the conclusion. We write the statements in symbolic logic. Then we write the premises and conclusion in symbolic logic. And then we now analyze the argument. So, statements in symbolic logic, we write P will be, here we have It is warm outside. It is warm outside. Okay, that's the first thing we see here. Q is I will walk at the park. I will walk at the park. So we've written the statements in symbolic logic. Okay? Then the next thing we do is to write the premises and the conclusion in symbolic logic. Okay? So we write the premises and conclusion. Now you might ask me, how do I know how many statements? Here the main statements are, and our statements should always be in the positive. Okay? Like you can't come and write, I will not walk at the park as Q. No. That is negation of Q. So our statement will always be in the positive. And the two statements here basically are, it is warm outside, I will walk at the park. That is the basically two statements that are here. I mean, you can say, hey, there are 3 sentences, I know. But these basic logical statements here, number 1, it is warm outside. Number 2, I will walk at the park. And our statements should always be in the positive. Okay? Even if they wrote, if it is not warm outside, then I will walk at the park. Our statement will still be, it is warm outside. We want our statements to be in the positive. Okay, so let's write, the next step is to write our premises and conclusion. Premise 1, our premise 1 is, if it is warm outside, then I will walk at the park. This is a conditional statement. P implies Q. P implies Q. If P, then Q. Okay, if P, then Q. Then our premise 2 is, I will not walk at the park, not Q. Our premise 2 is not Q. So our conclusion is, therefore, our conclusion is, therefore, 3 dots. This means therefore. Okay, you know, this means therefore. These 3 dots that look like a triangle, that resembles the shape of a triangle. It means therefore in mathematics. Therefore, it is not warm outside. Therefore, not P. Therefore, not P. So these are premises and conclusion. So, if you view the videos on arguments, okay, under the playlist on logic and truth tables, there are 3 ways you can analyze an argument. First method, you can use formula method. Okay, you can use formula method. Premise 1 and premise 2 implies conclusion. If it is a tautology, argument is valid. If it is not a tautology, if it is a contradiction or a contingency, argument is invalid. Argument is invalid. Second way is by definition. Okay? By definition, meaning that you check the cases where both premises are true. Okay? Check all the cases where both premises are true. And you circle them. If the conclusion of that case is true, argument is valid. All the cases where both premises are true. If the conclusion is true, argument is valid. Because that is by definition. Okay? A valid argument is an argument whose conclusion necessarily follows from its premises. Okay? If both premises are true, the conclusion must be true. All the cases. That means the argument is valid. If you have at least one case, okay, if you have at least one case whereby both premises are true and the conclusion is false, argument is invalid. Third method, is by checking it against, comparing it. Third method is by comparing the symbolic argument comparing it with the standard forms of valid arguments and the standard forms of invalid arguments. Okay, if you compare it. So if you compare this with the standard forms of valid arguments, you will see that this is a valid argument. Valid argument. But you have to state the reason. State the reason. Okay? Indeed, we have two more to go. So I will show you other methods, because you asked me, what if it is not a standard form of valid argument or invalid argument? Okay, we shall do that in the two questions following it. Okay, but to save time in this video, whenever you write the symbolic argument, the premises and the conclusion, if it resembles any of the standard forms of valid arguments or the standard forms of invalid arguments, go ahead and say it. So this is a valid argument by modus tollens. Modus tollens. Okay? Valid by modus tollens. Or you can say modus tollens is also a contrapositive reasoning. Contrapositive reasoning. Or you can say law of contraposition or law of contraposition. Anytime you see an argument in this form, premise 1, P implies Q, premise 2, not Q, conclusion, therefore not P, it is valid by modus tollens. Okay? Or law of contraposition or contrapositive reasoning. Okay? Alright, that is A part. Now let us do B. B part. 9B. Maybe states, if it is not warm outside or if it is raining, then I will not walk at the park. Okay? If it is not warm outside, okay, or if it is raining, or if it is raining, or if it is raining, if it is not warm outside, or if it is raining, then I will not walk at the park. Okay? If it is not warm outside or if it is raining, then I will not walk at the park. So we have warm outside, raining, walking at the park. We have now 3 statements here. Okay, this is premise 1 though. This is premise 1. Premise 2 is it is not raining. It is not raining. Premise 2, it is not raining. And then conclusion, therefore, I will not walk at the park. Therefore, I will not walk at the park. I will not walk at the park. Okay. So let us write our statements. Then we write our statements. Then we write our premise 1 and premise 2, and then we can use the we can use any of those 3 methods. Which one will work? Okay, any of them, and see which one will apply. Okay, let's write our statements first. Statements. I will need this because this is 3, so I will need this whole board. Statements first. Our P would be it is warm outside. It is warm outside. Our statements will always be in the positive. Okay? Our Q will be it is raining. It is raining. Our statement is always in the positive. Always in the positive. So P is it is warm outside. Q it is raining. And then R is I will walk at the park. I will walk at the park. I will walk at the park. Park. Am I pronouncing it right? With an American accent. Park. Okay, so these are statements PQR. Alright, now let us write our premises and conclusion. Premises and conclusion. Premises and conclusion. Okay, premise 1. Our premise 1 will be if it is not warm outside or if it is raining, then I will not walk at the park. So not P or Q. So this will be not P or Q if this implies not R. And put this in parentheses. Okay? Not P or Q if it is not warm outside. Warm outside is P, so not warm outside is not P. Or this junction, or if it is raining, raining is Q. Then, if then implies I will not walk at the park. So I will walk at the park is R. I will not walk at the park is not R. That is premise 1. Premise 2 will be it is not raining. So not Q. Okay? Not Q. It is not raining, not Q. Then conclusion will be therefore I will not walk at the park. Not R. Okay, let us now analyze this. If you look at this, we knock off the third method. Okay, we cannot use the third method here because this does not resemble any of the standard forms of valid arguments or standard forms of invalid arguments. It does not resemble it, no. So we can use the first method and or the second method to solve it. Okay, let's start with the first method, formula method. So remember the first method is, let me the first method, I hope this will be enough for me, I think so. The first method is premise 1 and premise 2 implies conclusion. Okay, premise 1 and premise 2 implies conclusion. So we have premise 1 and premise 2 implies conclusion. We have to draw the truth table for this. We have to draw the truth table for this. If it is a tautology, we draw the truth table for this. If it is a tautology, then it is valid argument. If it is a contradiction or a contingency, then it is invalid. Okay? So let me separate this with yellow. Now let's write this. Our premise 1 is not P or Q implies not R. Okay? This is our premise 1. Let me write this with double parentheses. That's okay. Premise 1. Okay? And premise 2 is not Q. Then implies not R. Implies not R. Okay. So we have 3 statements. And with 3 statements we have 8 possibilities. With 3 statements we have 8 possibilities. So we have our P, we have our Q, we have our R. We have not P, we have, you know what, since we've written this, so let me have more space, okay? Since we've written this, so let me have more space. Because I really need space too. So you can see it clearly. So this is what we need here. Not P or Q implies not R, and not Q, okay, implies not R. Okay? So let's draw the truth table for this. And then let's draw the truth table for it. Okay, so we have our P, we have our Q, we have our R. This is the first 3 things we will draw. Because it's 3 statements. You draw the first 3 statements first. Okay? Now we have not P, then we have not P or Q. Not P or Q. Okay? Then we have not R. Then we have not P or Q implies not R. Not P or Q implies not R. Implies not R. Okay? Then we have not Q. We have not Q. Then we have this and not Q. Okay? We have not P or Q implies not R. And now this is and, not Q. Okay? And not Q. and, not Q. And then we have the last one, everybody. Okay? We have the last one. Let's write the last one here. Not P and Q implies not R and not Q, then implies not R. Implies not R. Okay? So, I still like using double lines to demarcate this, so let me try and see. I like using double lines, but it's just my preference, okay? You must not. I use it to demarcate the statements from the truth values. Okay. I know my lines are kind of somehow, right? Okay, we have true, is 8 possibilities with 3 statements. True, 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 false, 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 false. Okay? Then for Q will be true, true, false, false, true, true, false, false. That is for Q. For R will be true, false, true, false, true, false, true, false. Okay. Not P. Not true is false. Not true is false. Not true is false. Not true is false. Please, let me make you an appeal, please. Let me make an appeal. So, some students write something like this. You don't know whether this is true or whether it is false. So please write properly. Because if you write this, I don't know whether it's true or false, and then it's wrong. So please write properly. Okay? Write properly. And use uppercase. The statements are lowercase. The statements are lowercase, while the truth values are uppercase. Okay? Use the standard norm. Use the standard norm. So, not true, false, not true, false, not true, false, not true, false. Not false is true, not false is true, not false is true, not false is true. Okay. Or, we're looking at false or true. Okay, false or true is true, false or true, or is true, false or false is false, false or false is false, true or true is true, true or true is true, true or false is true, and true or false is true. Okay? This is false or true, true, false or true, true, false or false, 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 true or true, true, true or true, true, true or false is true, true or false is true. Now not R, not true is false, not false is true, not true is false, not false is true, Not true is false. Not false is true. Not true is false. Not false is true. Okay, not R. Now this implies this. True implies false is false. True implies true is true. False implies false is true. False implies true is true. True implies false is false. True implies true is true. True implies false is false. And true implies true is true. Okay? And like I said, you can also use Google spreadsheets to check this, to check your work. Okay? True implies false, false. True implies true, true. False, false, true. False, true, true. True, false, false. True, true, true. True, false, false. True, true, true. Okay. Now, not Q. Not true is false. Not true is false. Not false is true. Not false is true. Not true is false. Not true is false. Not false is true. Not false is true. That is not Q. Okay, you now have and. False and false is false. True and false is false. True and true is true. True and true is true. False and false is false. True and false is false. False and true is false. True and true is true. And. Then you now have this here implies not R. Okay? So I'm looking at this column and this column. False implies false is true. False implies true is true. True implies false is false. True implies true is true. False implies false is true. False implies true is true. False implies false is true. True implies true is true. Okay, so this here, this statement is a contingency. See, because of this guy. So this is a contingency. So argument is invalid. Invalid argument. Because this is a contingency. Just because of this here. Contingency. Makes this argument invalid. That argument will not. Okay. Excuse me. That is first method. Formula method. Okay? Premise 1 and premise 2 implies conclusion. If it is a contingency or a contradiction, the argument is invalid. If it is a tautology, the argument is valid. Now, some of you might ask me, okay, do second method. Second method. Okay. If we need second method, then we only need premise 1, premise 2, and conclusion only. That's all we need. Okay? So if we need second method, this is what we need here. This is our premise 1. Premise 1. We need that. We need premise 2. Premise 2. Then we need conclusion. Conclusion is not our conclusion. So, with the second method, guess what? With the second method, we don't need this. With the second method, we don't need this here. Let me speak like American. We ain't gonna need all this. We ain't gonna need, let me speak like American. We ain't gonna need all this. Sure, we ain't gonna need all this. We ain't gonna need all this. We ain't gonna need all this. We ain't gonna We ain't gonna need all that. We ain't gonna need all that. True. We ain't gonna need all that. True. That is speaking like an American. Okay. Now with the second method, let us circle all the cases where both premises are true. Okay? Where both premises are true. Let us find all the cases where both premises are true. So, false, false, no. True, false, no. True, true. I circle this. I circle it. True, true. I circle it. False, false, no. True, false, no. False, true, no. True, true. I circle it. So these are the cases where both premises are true. Okay, now let us find the conclusion in those cases. Let's find the conclusion in those cases. Conclusion here is false. No, no, we don't want that. Conclusion is true. Okay, this is nice. Conclusion here is true. Good. But then, because we have at least one case, where you cannot have two premises and you have a false conclusion. You cannot. Because a valid argument is an argument in which the conclusion necessarily follows from the premises. Okay? So, because you have at least one case where both premises are true and the conclusion is false, this is invalid argument. Invalid argument. By definition. Okay? By definition. Okay? And that is it. Yeah, this 9b took us some time. Okay, let's go ahead and do 9c. And that will be it for question 9. Let's do 9c. 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 So I hope you understand this. And if you do not understand it, please feel free. If you are my student, which I assume you are, please feel free to ask me questions, not from my website, no. Okay, if you are my student, please do not contact me from my website, please. Contact me from the school email, please. But if you're not my student, that's fine. You can contact me from my website. 9c. We have, I will walk at the park if and only if it is warm outside. I will walk at the park if and only if it is warm outside. Okay, that is premise 1. Premise 2, I will not walk at the park. Premise 2, I will not walk at the park. Park, 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 park. Conclusion. Therefore, it is not warm outside. Therefore, it is not warm outside. Okay? Therefore, it is not warm outside. Alright, so first of all, let's write the statements. I think we have only 2 statements here, so we should be fine. So let's write our statements. In this case, our statements P will be, I will walk at the park. I will walk at the park. Q, it is warm outside. It is warm outside. Okay. Those are statements. Now let's write our premises. Let's write our premises and our conclusion. Let's do it. Can we do it here? Premises and conclusion. Premises and conclusion. Okay, so our premise one will be I will walk at the park if and only if it is warm outside. So P, if and only if, double arrow, Q. P by conditional Q. Okay, P by conditional Q. Premise 2. Premise 2 is I will not walk at the park. So not P, not P. So conclusion will be therefore it is warm, it is not warm outside, not Q. Okay? Therefore not Q. Alright? I will walk at the park if and only if it is warm outside. So P by conditional Q. Premise 2, I will not walk at the park. So that is not P. Therefore, it is not warm outside. Okay, yeah, not Q. Alright, so now let's, this does not resemble any of the standard forms of valid arguments or the standard forms of invalid arguments. So let us use first method and second method. I mean, you only need to use any of the methods, okay? You only need to use any of the methods. But let's go ahead and use first method, okay? Let's write the formula here. Premise 1 and premise 2 implies conclusion. Remember, this is premise 1, first method by formula. Premise 1 and premise 2 implies conclusion. If it is a tautology, it is a valid argument. If it is a contingency or a contradiction, it is an invalid argument. Okay, so this means here P if and only if Q and not P, okay, implies not Q. Alright, let's draw the truth table for this. So we have our P, we have our Q, we have P if and only if Q, okay, P by conditional Q, P by conditional Q, we have not P, we have this and this, okay, we have P by conditional Q and not P, okay, then we have not Q, then we have everybody. Okay? P by conditional Q, P by conditional Q, and not P, okay, implies not Q. Okay. So I like using double lines. I'll use double lines to do this, to demarcate the statements from the truth tables, from the truth values, okay? To demarcate the statements from the truth values. Okay, so two statements has four possibilities. True, true, false, false, true, false, true, false. So I have true, true, false, false, true, false, true, false. Okay? Biconditional true, biconditional true is true, true, false is false, false, true is false, false, false is true. True if and only if true is true, true if and only if false is false, false if and only if true is false, false if and only if false is true. Not B, not true is false, not true is false, not false is true, not false is true. And, true and false is false. False and false is false. False and true is false. True and true is true. Okay? Not Q. Not true is false. Not false is true. Not true is false. Not false is true. Implication statement, conditional statement. False implies false is true. False implies true is true. False implies false is true. True implies true is true. So this argument is a valid argument. I will walk at the park if and only if it is warm outside. I will not walk at the park. Therefore, it is not warm outside. That is a valid argument. So this is a tautology. 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 Valid argument. Valid argument. Okay? If you want, I can write it here. Okay? It is a tautology. Tautology. Argument is valid. Valid argument. Okay, that is method, first method. Another way we can do it is premise 1, premise 2, conclusion. Okay? So let's identify it. Our premise 1 is this here. Premise 1. I'm using another color of chalk to write it. Our premise 2 is not P, this is our premise 2. And then our conclusion is not Q. Conclusion. So these are what we need here. Excuse me. So we don't need this here. And we don't need this. We don't. For the second method, okay, first method, this is it. Second method, we don't need this here. If you are using second method, and you don't need this here. If you are using second method, we ain't gonna need those. We ain't gonna need those. That is American way. We ain't gonna need those. Okay. Let us circle all the cases where both premises are true. Let us circle all the cases where both premises are true. So true, false, no. False, false, no. False, true, no. True, true. Yeah. Only one case. No problem. Let us check the conclusion in that case. And the conclusion is true. See? So this argument is valid by definition. Valid by definition. Okay, so someone might ask me, okay, listen, see, what if there are no cases where both premises are true? Okay, what if we checked no cases where both premises are true? Then the argument is still valid. Okay. Now, the only time the argument is invalid is we check both cases where both premises are true, and if we have at least one case where the conclusion is false, then the argument is invalid. But like this, we have only one case where both premises are true, and the conclusion is true, the argument is valid. Okay? Or if there are no cases at all where both premises are true, the argument is valid. Okay? So you can use first method by formula, or you can use second method by definition, or you can use third method if it applies. Third method is by comparing it with standard forms of valid arguments and standard forms of invalid arguments. Okay, so we are done with question 9. Okay, now what questions remain? Questions 10 and 11 are mathematical induction, but let's just, I don't know how long we have spent, but let us, I think we have finished propositional logic. Let's go ahead and do predicate logic, questions 3 and 4, and we can call it a night. Then part 3 will now be the questions 10 and 11. Okay? So let's go ahead and do predicate logic, questions 3 and 4. Predicate logic. Predicate logic. Predicate logic. Predicate logic. Propositional logic. I think this, if you don't understand anything, please let me know. Please let me know. Please let me know. Okay, predicate logic. You have 2 questions on that. Let me just lift it open. Write it again. Okay, question 3. Let me find a similar one. Write the statement. Every number is less than e squared. Okay, write the statement. Every number is less than e squared. Okay, you can finish up the writing. Write the statement, every number is less than e squared. Symbolically, they want you to write it symbolically by first defining a predicate and then using a quantifier. We have to define a predicate first, then we use a quantifier. Okay, so let's that's just it. So let's go ahead and define the predicate. Okay, the predicate. Let's P of x be the predicate. So we can write P of x okay, such that x is less than e squared. X is less than e squared. So this is in English, but they want us to write, let's write it in math. So P of x such that x is less than x squared. X is less than x squared. Okay? Where x is the number. X is number. X is less than e squared. So predicate logic. That's the predicate. X is less than x squared. Then the next question is, this is just defining it using predicate. Okay? Excuse me. Then the next question is by first defining a predicate and then using a quantifier. So the quantifier here is a universal quantifier, every. Every is the universal quantifier. Okay? Every is the universal quantifier. So the answer will now be for all, just like your all upside down, A upside down. For all x, okay, then P of x. And this is your answer here. For all x, x is less than x squared. That's the answer. Or you can say for every, it could be for all. Like your A, all, put it upside down. It is a universal quantifier. Okay? For all x, x is less than e squared. X is less than x squared. And that is the answer for question 3. Now, question 4. Question 4. They give you here, they give you the predicate. Okay? Here they give you the predicate. Let P of n be such that, okay, they define the predicate, n cubed is equal to n squared plus 6n. N cubed is equal to n squared plus 6n. Okay? Now, they now said, A, what is P of 2 as a statement? P of 2. What is P of 2 as a statement? Okay? So this means anywhere we see n, we put 2. Anywhere we see n, we put 2. So this means that P of 2 is such that 2 cubed is equal to 2 squared plus 6 times 2. Okay? So this means 2 cubed is 8 equal to 2 squared is 4 plus 12. So 8 is equal to 16. We know that 8 is not equal to 16, right? So the truth value for this is false. Okay, but that is for it. We can't say it for all. Okay, but let's see whether it might work for some. Okay, so this is the first one. Right? What is P of 2 as a statement? That is A part. B part, B is, what is P of 3 as a statement? P of 3 as a statement. So P of 3 is such that 3 cubed is equal to 3 squared. Anywhere you see n, you put 3. Anywhere you see n, you put 3. So this is such that 3 cubed is equal to 3 squared plus 6 times 3. 3 cubed is 27. Okay? 3 times 3, 9 times 3, 27. 3 squared is 9 plus 6 times 3 is 18. So 27 is equal to 27. So you see here, for this predicate, okay, it worked for 3. n equal to 3, but it did not work for n equal to 2. It did not work for n equal to 2, but it worked for n equal to 3. Now, C part, okay? C part says, what is the truth value? What is the truth value of all, for all n, such that n cubed is equal to n squared plus 6n? For all n, such that p of n, what's the truth value? Well, you could see for all n universal quantifier, p of 2 did not work. Okay, this is false. It's F. Because 8 is not equal, is p of 2 is false. Okay, 8 is not equal to 16. P of 2 didn't work. So you can say for all n, p of n, that will give you false. If you say for all, if you say for all, then it's false. Okay, because this is a universal quantifier. If you call this true, that means it will work for any value of n. But it didn't work for 2 because 8 is not equal to 16. Okay, then the D part, D says, what is the truth value of there exists n, p of n? Okay, so this means there exists, like your E rotated the other way. There exists n, p of n. Okay, this one, the truth value is true. Why? Because we see that it worked. P of 3 is true. 27 is equal to 27. So for all, this is an existential quantifier. This is a universal quantifier. You can't say for all n, this rule is true. No, because it didn't work for P of 2. However, what you could say is that there exists some value of n. There exists some value in the domain. Okay, so there exists some value of n in the domain such that n cubed is equal to n squared plus 6n. And how did we find out? P of 3 worked. Okay? That is it for question 4. Alright, folks, it remains 2 questions, 10 and 11. Okay? Please watch out for part 3. If you are my student and you have any questions on this, please feel free to contact me via the school email or school system. If you are not my student, then you can contact me through my website. If you are my student, please do not contact me from my website. Okay? Thank you so much, and you have a good evening.